Okay, so welcome to the second part of the tutorial on the behavior tree prototype. So what I'm gonna do in this part is that I'm gonna introduce really the concept behind the behavior tree. So the behavior trees are it's a control structure, just a structure that represents some kind of process or composition, and it does so by it represents it as a nested set of nodes or tasks. So each node of that tree represents a single task to perform. So you can imagine, for example, a task could be something very simple like sending an OSC message or printing some text or changing some variable. Or it could be something much more complex. So for example, it could be something like telling a robot to go onto the other side of the room. Now, each node, when it's called, is going to return only one of three states. It's either going to return success, failure, or running. So, for example, if we look back at this robot example, given the task to go to the other side of the room, every time I call the robot, it's while it's moving to the other side or trying to, it's going to return the state running, meaning that it's currently still trying to perform the task. If it reaches, or once it reaches its destination, it's going to stop and return success. And if for whatever reason its batteries run out, if it just finds there's an obstacle, it can't go to that side of the room, or there's some kind of a timeout, it will stop and return failure. Okay. So that's the first thing to understand. And the other thing is that there are basically two kinds of nodes. There's the leaf nodes, or the unit nodes, if you want, that are very just like the actions that represent a single action. It's usually really short, and sort of it's really atomic. And then the other kind of node is called composite nodes. So those are more like control structure. They usually have children. They have children nodes, and they're just going to prescribe a way to activate their children. So let's start with a simple example by adding in an atomic node. So to do that, I'm going to type Control Tab. And this brings up this nice little list. And it's an autocomplete list. So I'm going to start typing. We're going to start with a constant object. So if I start typing like CON, see like I can autocomplete it using the tab key. And then I can continue and give a list of arguments. So in this case, the constant node takes one argument, and I'm going to write success. Okay, so I'm going to create this node, then I type enter, then it's created, and let's see what happens if I run this program. It's very stupid, very simple, but it's just to illustrate the process. So now in this tree I have one action, one node. It's a constant node that always returns success. Okay, so I run it, it returns success, it finished with the success state. I could change it by selecting it and typing Control E for edit, and I'm going to remove success and write failure instead. Okay. So again, Control Space, I run it. Now this time this node fails because that's what it does. Okay. And finally, if I type Control E again and I type running here, okay, I'm going to create a constant node that always returns the running state. Control Space, I see that it's always running. If I press space again, I will pause it, and so on. Okay. If I want to return to my original state and sort of reset the sketch, I can type Control R to do that.